All right, the last video, we just went over the definition. We went over a lot of the parts of this. So now let's get into an actual equation. My equation of ellipse is going to change depending on a lot of different things here. But when it is centered at 0, 0, I know it is centered at the origin because it's only x squared and y squared. If you look at your formula sheet that I give you, when the center moves and is not at the origin anymore, you're going to have what kind of looks like a circle where you'll have x minus or plus a number and y plus or minus a number, and that's going to give you that HK. So if you just have x squared and y squared, we know it's at the origin, right? Because that's the same as x minus 0 and y minus 0. And then we know the major axis is along the x-axis when my a squared is under my x. Now, we can always tell where a squared is because a squared is going to be the bigger of the two numbers. And that's what it says right here, that a is greater than b, which is greater than 0. So these are both going to be positive, and I know where a is because a is going to be bigger than b. So when you have x squared over the bigger number plus y squared over a smaller number, we know that the major axis is along the x-axis. The equation of ellipse is centered at 0, 0. We already went over that. Your foci are labeled as your C, and your vertices are labeled as A. So this is again your major vertices, okay, which is the longer of the two. And so it doesn't even label it here, but your minor vertices are your B. And then the foci are right here inside the ellipse. Now what's going to happen, you will always be given A. You will always know where your major vertex is. Sometimes they're going to give you the foci and you have to find B. Or you will be given the major vertex and the minor vertex and you have to find C. Very, very rarely do they give you everything you need. So this formula here is what you will use to find whatever piece of missing information that you're lacking, because we need everything when we graph. We need the center, we need the major vertices, the minor vertices, and your two foci. Now this comes from Pythagorean theorem. Okay, let's see. When you have Pythagorean theorem, this is only for right triangles. We usually call the legs A and B, and then what's across from the right angle is your C, your hypotenuse. And so Pythagorean theorem states that A squared plus B squared equals C squared. Your leg squared plus your other leg squared equals the hypotenuse squared. Well, that's essentially where they came up with this formula at. It's just they're not labeling the two legs A and B and the hypotenuse C. When you look at this right triangle that they have one leg as B, so this is B squared, plus your other leg is C squared, and this equals the hypotenuse, which is A squared. And so to solve this for B, all they did was subtract the C squared over. So they got B squared equals A squared minus C squared. So that's where that formula comes from. Okay. So I know everything I just said, probably none of it really made sense, but it will make sense, hopefully, by the time we are done with this example. So let's use all of this information right here with example 1. says find the equation of the ellipse centered at the origin. One focus at 2, 0 and a vertice at 4, 0. Graph the equation. Okay. So I'm just going to kind of start plotting some stuff. I have the center at the origin. I have one focus at 2, 0. So 2, 0, and I'm going to label that as an F. Your focus is always equal distance from your center. So if one focus is 2 units away, I can go 2 units the opposite direction here to make this my F. So my foci are 2, 0 and -2, 0. Okay, I have one vertice at 4, 0, which is right here. And so same thing. This vertice is equal distance from your other vertice from the center. So if this is 4 units away, I can go 4 units in the opposite direction. And this is my other vertice. Okay, and I'll even put capital M for major vertices. Now they only call, when they say vertex, right, or vertices, they're talking about the major always, but I like to label them. So here, my vertices are at the ordered pair 4, 0 and -4, 0. Okay. So my focus are always labeled as my C. My vertex is my A. So what I don't have to write this equation is my B, because my B is x squared over a squared plus y squared over b squared. And I didn't mention this, but this is always going to equal 1. Okay. So we will use this formula here to find my B so I can plug it in to my formula. So B squared minus or equals a squared minus c squared. Plug in your information. I don't know B squared. My A is 4. And my C is 2. So B squared equals 16 minus 4. B squared equals 12. So to solve for B, got to get rid of that squared. And the opposite of square is to take the square root. So B equals, if I break down 12, that's 4 and 3, which is 2 and 2. So a pair of 2's come out, and that 3 stays in. Now, to graph it, we're going to need a decimal equivalent. So 2 square root 3 is about 3.5. And you can also just do the square root of 12. And my math lab's going to want that. And so now I can even put in my minor vertices. So this is up 1, 2, 3.5. And down 1, 2, 3.5. So I will make the best ellipse that I can for right there. Bottom's way better than the top. Hey, we kind of did this backwards a little bit, but it all goes together. We are supposed to graph the equation, so check, but I do need to find the equation, and so we're going to plug it in to this. So I'm just going to rewrite what my formula is real quick, and then plug in. We'll have x squared over a squared. My a is 4, 4 squared, 16, plus y squared over b squared. I'm not going to really look right here. I have found what b squared was. B squared was 12. Ooh. And then equals 1. So here is my equation. And the closer that these two numbers are together, the more circle-like that's going to be. Once these get further apart, that's when it's going to look way more oval and stretched and less circular. Okay. There's a lot going on here, but hopefully we're kind of catching on some, right? Okay, so let's try another example. We need to analyze the equation. Analyze the equation, x squared plus y squared, x squared over 25 plus y squared over 9 equals 1. All right, so it says that is, find the center of the vertices, the foci in the ellipse, and graph it. Okay, so my equation is usually x squared over a squared plus y squared over b squared equals 1. I know that it's x squared over a squared because my a is always going to be my bigger number. Okay, so the center. Well, because this is x squared y squared, I know that my center is 0, 0. So I'm going to go ahead and slap that on my graph. There's my center. Okay, my vertice has to do with my A, right? That's what this right here stated. My vertice is at negative and positive A. So my A squared here equals 25. So take the square root of both, and we're going to get A equals plus or minus 5. So from the center plus 5, and from the center minus 5. So that means my vertices here are 5, 0, and negative 5, 0. I need my foci, and I don't have that information. My foci is represented by C. I don't have C. What I do have, though, is my B squared. So here, B squared equals 9. So that means B equals plus or minus 3. Okay, so for my center, I can go up 1, 2, 3, and I can go down 1, 2, 3. All right, so this actually gives me, like, this equation is enough to graph this. And you can see this one is a little bit more oval-like. Mine looks more like an eyeball, but it should be more oval-like because these numbers are further apart from each other. Okay. Okay, so I have A and I have B, but I need C for the foci. And so that's where this formula comes into play. So we have B squared equals A squared minus C squared. My B squared is 9. My A squared is 25. And that's minus C squared. So subtract your 25 over, we get negative 16 equals negative C squared. Divide both sides by negative 1 to get C squared is 16. And then take the square root to get plus or minus 4 equals C. So then my foci from the center is 1, 2, 3, 4. And 1, 2, 3, 4 to the left and to the right. So those ordered pairs are 4, 0, and negative 4, 0. Okay, and so now we have done everything that it is. We have analyzed the equation by finding the center at 0, 0 because it's x squared, y squared. We have found the vertices, that's my A, so we just took the square root of 25. And we found the foci. We found the foci by using our formula to solve for C, and then we graphed it.